All right, let's dive right into this explainer. Think of this as your personal mentorship masterclass. We're going to set the stage for what it actually takes to future-proof your engineering career in the age of AI. We're looking straight ahead at the shifting landscape of 2027. And look, if you're building software right now, you absolutely need a rock-solid strategy to navigate it.
So, welcome. I'm going to give you a pragmatic, totally no-nonsense senior engineer's perspective on the real state of AI right now. Not the hype version, the real version. We're going to cut entirely through the noise, skip the fluff, and look at the cold, hard facts of where the industry is actually at.
Because honestly, there's such a stark contrast between the mainstream hype and the baseline reality that enterprise AI has already hit today. Like, the hype is all about basic chatbots and simple API wrappers, right? But the reality, it's so much deeper. We've got reasoning models already deployed in production. AI agents are out there autonomously completing real, complex, multi-step tasks. Pretty much every major enterprise is deploying agents right now. And the best open source models, they're genuinely competing neck and neck with the big frontier closed models. So this isn't science fiction anymore. This is just where we are. So here's our roadmap for this explainer. We'll cover 1, the current AI baseline, 2, defining industry shifts for 2027, 3, navigating global AI regulations, 4, high-value career specializations, and 5, building your professional moat. All right, kicking things off with Section 1, the current AI baseline, and exactly where we stand in May 2026. Moving right along to Section 2, defining the massive industry shifts for 2027, or basically, the tidal waves hitting our industry. Now, the single biggest near-term change we're facing is a massive UX shift. Right now, most agents have what I like to call 51st date syndrome. They literally start fresh every single session, zero memory. But by 2027, mainstream AI is going to be persistent. These agents will maintain context across days, weeks, even months. They'll know your calendar, they'll understand the ongoing projects you're tackling, and they'll seamlessly adapt to your specific communication style. And let me tell you, this entirely alters how we need to architect and build software. And the crucial point driving all of this is this absolutely staggering number, the current cost per 1,000 tokens for highly capable models. It represents a massive, massive cost compression. Just think about it. Back in 2020, GPT-3 cost 2 cents per 1,000 tokens. Today, equivalent capabilities cost a tiny fraction of a cent. It's wild, and this compression is just going to keep going. By 2027, running a capable AI model locally will cost essentially nothing for most applications, which means compute cost, that's no longer your bottleneck. System design is. We're also seeing some massive standardizations on the horizon. Take Google's agent-to-agent, or A2A protocol. This is huge because it allows agents from entirely different platforms to actually interoperate. This means an agent you build can literally hire agents built by someone else to complete subtasks. Imagine your personal calendar agent negotiating directly with a restaurant's booking agent to secure a table for you. Just wow. Simultaneously, we're seeing the explosive rise of physical AI. Companies like Figure AI and Agility Robotics, they're deploying humanoid robots trained with the exact same techniques that power language models. They're coupling that deep reasoning ability of LLMs with actual physical manipulation in the real world. Now, sure, while this is maybe 2 to 3 years away from widespread consumer impact, it is happening right now today in industrial settings. That brings us to Section 3, navigating global AI regulations and designing around some very real legal realities. Look, if you're building AI applications, you have to impartially navigate a really complex global web. In the US, there's this patchwork conflict going on between a federal light touch policy and very specific state laws, like in California, which require frontier AI safety disclosures. Then, over in the EU, the AI Act places some seriously strict transparency and compliance requirements on high-risk applications, think medical or critical infrastructure. And over in China, there's comprehensive regulation that actually demands algorithm registration and strict content moderation, though, to be fair, their labs are still advancing rapidly within that environment. These aren't just legal problems for lawyers to worry about. They directly impact your development plans. They'll often require you to slow down your sprint cycles just to build distinct compliance guardrails for different regions. So, what you should really take away from this is that if you're building in highly regulated sectors like finance, healthcare, or legal, these regulatory requirements are very real and they are only increasing. To protect your systems, you absolutely must implement a specific audit trail checklist into your core engineering workflow. First, you have to thoroughly document your training data. Second, build and record rigorous safety evaluations, utilizing methods like red teaming and automated prompt fuzzing. And third, you must ensure deep system explainability. You just cannot deploy a black box in a highly regulated industry anymore. It won't fly. All right, Section 4, High-Value Career Specializations. Basically, the survival guide for engineers.
Let me be brutally honest with you for a second. Knowing how to call an API or write a simple REG pipeline, that is now table stakes. Basic prompt writing for standard tasks, that's completely commoditized. Those things are no longer going to differentiate you. The true value now lies entirely in the essential technical skills: systematic evaluation engineering, output validation, and architecting incredibly reliable, error-handling, multi-agent workflows. Here's a breakdown of the highest leverage engineering skills you really need to cultivate right now to map to these industry shifts. First step is evaluation engineering. This is all about building systematic evals and measuring what your AI system actually does in the wild. Next is agent system design, which requires you to master architecting multi-agent workflows, handling complex errors, and managing state. And then there's inference optimization. Knowing how to run AI cheaply and reliably via quantization, batching, and caching, that is a highly specialized skill that literally saves companies massive amounts of money. If you want to master evaluation engineering, I highly recommend following this specific learning path because, frankly, knowing how to systematically measure what your AI does is incredibly rare right now. Step 1. Start by building real AI systems with concrete requirements. Step 2. Meticulously measure specific operational failures. Step 3. Debug and systematically handle those pipeline errors. And yeah, that part will probably make you want to pull your hair out. And finally, Step 4. Iterate to make those systems undeniably reliable. The industry desperately needs engineers who can make systems bulletproof, not just someone who knows how to make a demo look good once. Alongside optimization, mastering specific AI security principles is rapidly becoming an elite, super high-demand discipline. As these agents become more persistent and start acting autonomously, defending against things like prompt injection, enforcing really strict output validation, and designing robust agent permission systems are absolutely critical. You have to ensure adversarial robustness because, trust me, these systems will be targeted. It's a constant, high-stakes game of cat and mouse. Finally, Section 5, Building Your Professional Moat. We are talking about the ultimate meta skill. First, we kind of just have to acknowledge what nobody actually knows: the honest uncertainties. Anyone out there giving you a precise timeline on true AGI, whether they're saying it's 2 years or 20 years, they're overconfident. The speed of economic displacement, genuinely uncertain. Economists are literally running their models in real time trying to figure it out. Long-term regulatory stability is up in the air. And let's face it, the history of AI is filled with unexpected capability surprises. We've seen things emerge out of nowhere and predicted things that completely failed to arrive. Because of all these massive uncertainties, you must build flexible architectures that can weather the storm. So the most valuable meta skill in the industry right now, it's having the hard-earned experience of actually debugging and fixing real-world AI failures. The experience gap is simply the biggest gap in the industry right now. Engineers who deeply understand AI systems, who don't just use them, but truly understand their failure modes, they're going to be dramatically more valuable. The infrastructure layer of AI is honestly the least crowded and most durable opportunity out there for you. So build things, break them, and deeply understand why they broke. Because that hard-won understanding, that simply cannot be commoditized. No way. I really hope this structured masterclass explainer has helped you see past the hype and identify exactly what skills you need to cultivate for 2027. The landscape is shifting incredibly fast, but the path forward is actually quite clear if you know where to look. I want to leave you with this final thought. Drop a comment below and let me know. Exactly how are you building your professional moat today? What are you building with AI right now?